Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In the last few videos we looked at the nature of XML as a file format, and in this lecture and the ones after it we're going to start looking at how we can utilize XML in our Scala programs. And it turns out that part of the reason why I can cover Scala in the first half of a CS1 or in a CS1 class is because Scala makes XML so easy. You have XML libraries in languages like Java and C++, but they're far more complex. And to illustrate just how easy this is, let's go ahead and let's bring up an RAPL. And it's so easy, literally, you just type your XML directly into Scala, and Scala understands it. So that is a perfectly happy Scala expression there. You'll note the type here. It comes back as a scala.xml.element. It is an element. And so it's really hard to get much easier than this. It's worth noting that the complete integration of XML in Scala is something that not everyone likes. In fact, it's somewhat lamented. It's possible that after I've made this video at some point they might decide to take it out. But at least for now, it's in there, and it really makes it so simple to work with XML inside of your Scala programs that even a beginning computer science student can do it. And I can't say that that's true for using XML inside of many other languages. So you can write your XML directly inside of a language. How do we know what we can do with XML? Well, just like with everything else, we turn to the API. There is a scala.xml package. In fact, there are several packages that start off as scala.xml. And we can look inside of here. There was this elem, which we saw is what we parse to if we type in an element. And you might notice that some of these methods are things that you're used to seeing in things like a list, and that is because an elem is actually some type of a node, and the node is a subtype of the node sequence. And so when this is the kind of the fundamental way in which XML is represented inside of a Scala program is as a sequence of nodes. And nodes can be elements. They can also include other things like comments or flat text. Okay, all the things that you can put inside of XML are represented as nodes, and the contents, for example, of one node would be a sequence of other nodes. So that's how things are structured in there. And you can, as you saw, you can put this directly into your Scala program. We can also load in files. And so what I'd like to do is we'll quit out of the RAPL and let's write a grades.scala. And I am going to import everything from the XML package. And what I want to do is I want to read in this file. Now, to read in the file, we're going to turn to a slightly different type here in the API. We're going to look at the XML object, and XML has a method inside of it called load file. And so we call load file, we pass it a string, and it passes us back an element. That sounds pretty simple. So val grade XML equals XML.load file, and our file is called grades.xml. That was the file that we wrote over here. And just to make sure that it works, print line grade XML. That'll be the output of our script when we run it. And there you go. Yeah. So it's very, very easy to read in an XML file inside of your Scala code. Once you've read this in, Then the question is, well, how can you find stuff inside of it? Okay, so having all of these grades, I got back one element, which was the whole grades node, or the grades element. It spans everything. And it has contents of student, student, and student inside of there. So how can I get those things out? Well, there are two basic operators that we use for searching for things inside of XML. And they are backslash and double backslash. Now, these might seem like odd ways of doing things, but it turns out there's a standard XML library called XPath. And in XPath, you look for things using / and double /. In Scala, they couldn't use this because double / is, of course, a comment. So they went with the backslashes instead, and it winds up still being just as easy to read. So if I want to find all the students inside of the grade XML, I do a backslash, and then I tell it what I want to search for. And now instead of printing this, let's print line students. And this printed out, it's a sequence, and so it prints out the first student followed by the second student followed by the third student that's in there. Okay, so that's our sequence of students, and it was very easy to get hold of, and then I can search for things inside of there. Let's say I just wanted to search for every student's names. Well, what I could do here, because each one of these students is a node, but now I'm not searching for another element inside of it. Now I'm searching for an attribute. And so if I want to search for an attribute, I'll use X as short. Actually, let's do E, short for element. So I get a student element in here. And what I want to do is I want to search that element for, I want to look up its name. I can't just type in name though, because that would be, if I just typed in name, it wouldn't be looking for the attribute called name, it would be looking for all of the sub-elements called name. If you're looking for an attribute, you put an @ sign in front of it. So if I look for @name, that will pull off all the names. And then let's go ahead and make a string out of that. We'll put some new lines between stuff. And there we go. We were able to get hold of the 3 students' names. If I wanted to pull off their quiz grades, I could do that. Now you might be wondering, I said earlier that there was also a // but I haven't used that. It turns out I don't find much use for that, but I'm sure there are some very good uses for it where it can speed things up dramatically. If I do, let's do print line grade XML / quiz. Okay, I'm looking for quiz inside of grade XML. That's this blank line here. It didn't find anything. And the reason is because a single backslash only looks one layer down. So grade XML is this node here. So the only things that it's going to find one level down are student, student, comment, and student. Okay? Everything else is nested deeper. That's what the double backslash does. Double backslash goes into multiple levels searching for stuff. So it recursively descends into your XML. And so when I run this, you'll notice that this winds up pulling back up every single quiz grade that was in there. The problem with doing this, and this is why I don't often use the double backslash, is because I've now lost which student those quizzes were associated with. So you would have to have a situation where you're looking for things that are deeply nested, but you don't care about what their parents are. And that's probably a more rare situation than the situation where you do care what their parents are, in which case you do a single backslash, you find the parent node, and then you do another single backslash off of the parent node to find the stuff inside of it. So that's enough for this video. We'll come back next time and we will use this to write some functions that convert from our XML format here and build up a case class. So I want to store this information inside of a case class instead of being inside of the XML, so that I can work with it more easily in doing my my Scala program.